Okay, welcome everybody to Operations on Functions, which is the brand new unit and also the shortest unit in this course. Okay, this is only going to take us maybe a week and a half to get through. And if you think about the word operations in math, you basically think of order of operations, which is multiplication, division, addition, subtraction. Those four operations is basically what we're going to be doing in this first section. We're going to take a look at adding, subtracting, and eventually multiplying and dividing two or more functions. So we have some notation that I just want to introduce you to in the very beginning here. Up top, we have two examples of shortened notation if you add or subtract functions together. In this case, the functions are f and g of x. You can see on the right side here how you can simplify those to be a little bit less writing. All right, so you're going to see that notation a lot, f plus g of x, f minus g of x. And then in the first example, we are given three different functions, an f, g, and a k of x function, and two of them are linear, one is a parabola, but the shapes they make in this case don't really matter. We're not doing any graphing, it's just algebra. So in question 1a, you are asked to determine a new function, h of x, which is adding f and g together. So let's take a look at this. Okay, we can add f and g together somewhat. I can take 2x plus 1 and add it to x squared, but at this point, that's about all I can do. The only thing I can suggest to really do here is you could possibly put it in descending order. You could also maybe factor, but that's not going to do anything because we're not asked to graph or get x-intercepts or anything like that. We're simply asked for h of x. What I would say is that in the case where you have some like terms, you can add and subtract those to simplify things. You're going to see that in example C coming up soon. In question B, we're asked for a specific value, h of 4. Just a reminder that when you see a number in the brackets, you plug that in for x. So if I'm looking for h of 4, what I'm doing is I'm plugging in 4 wherever I see x, and it's going to look something like this. That's taken from the above h function, and just plugging in 4 where I see x, and now I'm going to use my order of operations to solve for this. So I do exponents first, and then I do multiplication, and now I can do addition, and I see that h of 4 is equal to 25. Okay, well, that's easy enough. That's nothing too difficult. And then you see here in j of x, I'm asked to do subtraction. So my j of x function is going to be f of x minus k of x. So I have f of x is 2x plus 1 minus k of x, which happens to be a minus 5x. And in this particular case, we can do some simplification. Okay, we have two negatives together. I can make that a plus. And then I can also collect some like terms here. So you can see that the 5x and the 2x I can add together to give me 7x. And you can see right here that we've solved for a function, j of x. So we're just adding and subtracting functions, and in some cases, evaluating at specific x values. Okay, this is a graphing example, all right, but no equations are given. These are definitely two linear graphs, and we are asked in this particular case to not determine the equation of f plus g of x, but to actually sketch that graph. So what we can do is we can just start picking points, and we can look at x values, and we could, we're going to add y values together, much like those reciprocal functions from the previous unit. So say, for example, I look at one particular x value of, say, x equals 4. Then what I have here is I have two corresponding y values, and I have to do f plus g. So what you're doing is you're adding the y values, and then you're going to plot your new point on this new y. So here I have an f value of positive 5 and a g value of negative 7. And if I add those together, I get a negative 2. So what I do is I just put a point down at my new y value of negative 2. So I'm not moving left or right. I'm not moving on different x values. I'm adding up my y coordinates for any specific x value, and I am plotting that new y point on the same x value. So I just move up or down to my new y value. Then we go over to the left a little bit and pick x equals 3. We have a y value of 4 and a y value of -6. And again, we get -2. So when I add this 4 to this -6, I get a -2, and I plot that point there. And then one thing you're going to find out is that as we continue to go through this journey, all the solutions when I add together are giving me -2. It doesn't always produce a horizontal line. It just happens to in this particular example. You can see that my new graph right here, drawn over the original graphs, is the graph of h of x, which is composed of f plus g.